the next high level representation that we will be looking into is known as directed acyclic graph. So, the previous representation that we had, that was a tree. So, syntax tree, and now this is a graph, and you know that as a data structure the difference between tree and graph is that in case of tree every node has got a unique parent node, and so that parent is only one. Every node has got at most one parent. The root node does not have any parent, but otherwise like if this is a tree, so the tree is always like this. So, every node will have one parent excepting the root node which does not have any parent, but it is never the situation that one node has got two parents. So, that if that thing occurs, then this is a graph, and we call it a directed acyclic graph where these edges are directed. So, from root node, so it has got children, so left and right children. So, similarly from here, so this is there. So, and then at some time, so if it is a graph, then this type of edges will also be coming, and it is not cyclic. So, this is an acyclic graph. So, we do not have a situation where say like this. So, we do not have a situation like this where it creates a cycle. So, this is not there. So, this type of representation, directed acyclic graph representation, so that is also used in many such intermediate language. So, it is similar to syntax tree, in which common sub expressions they are represented by a single node. So, like in the previous example that we had looked into, so it was like this, that if x greater than 0, then x equal to 3 into y plus 1, else y equal to y plus 1. Now, in this case, so this y plus 1 part, so this expression part, so this is becoming common. Okay. So, if you look into the parts tree, so in different portions of the parts tree I was evaluating this this y plus 1. So, one in the then part and another in the else part. So, in both the parts, so we were evaluating that. So, in case of directed acyclic graph, so what is done is this common expression, common sub expression, so they will be represented by a single node. So, we do not I do not keep a separate pointer like this. So, this also points to this one only. So, that way it is helping, like say here y plus 1. So, this node computes y plus 1. So, it was used in this expression also, that 3 into y plus 1, and it is used in this statement also, like y equal to y plus 1. So, in both assignment and both the assignment statements. So, this y plus 1 expression was common and that is taken out. So, that gives rise to a graph representation, and we will be we can go for a directed acyclic graph representation for that. So, that is one type of representation. Then there is another high level representation which is known as P code. So, this is used for stack based virtual machines. So, what is a stack based virtual machine? So, virtual machine means the machine does not exist in actual. Okay. So, this is a conceptual machine, you can say. Maybe there are some machines which are built around this concept, but it is but the basic idea is that this is a stack based machine. So, like if you look into this computer architecture, then there are different types of architectures that we can think about, or we can come across. One is known as accumulator based architecture. So, in accumulator based architecture, what happens is that all the arithmetic logic operations that you are doing, one of the operand and the result, so that is always the accumulator. Like you have got instructions like add b, which will mean that the accumulator a will get a plus b. Okay. So, this accumulator becomes a very important register, and that way all the operations, arithmetic logic operations, the accumulator is a part of it. On the other hand, this stack based machines, so it will assume that we do not have any such registers or things like that. Rather, there is a stack, and whenever any operation is needed to be done, so it will assume that the operands are always available in the stack. So, any operation to be done, so it will be taking out two topmost entries, do the operation, and then it will be pushing the result back onto the stack. So, it is like this, that suppose I have got say this one say x equal to y into z, then what it will do? It will have this it will be putting this y and z into the stack, and then when this operation has to be done, so it will take out this z and y from the stack. So, you can say that it as if it will be doing two pop operations to get this y and z, then after that it will do a multiplication operation, or in some sense in some cases you can say that the multiplication operator automatically it will pop out two topmost entries from the stack and do the multiplication on them, and then it will push the result back onto the stack. So, it may be like this, that is suppose I am doing this operation. So, multiplying two expressions E 1 and E 2, okay, sub expressions E 1 and E 2. So, somehow we already have got the code for evaluating E 1, code for evaluating E 2, and then I say multiply. So, when it is there, so that will mean that the operands after finishing this code to evaluate E 1, the final result is already put into the stack. So, the final result of E 1 is already available in the stack. Then we have got the code to evaluate E 2. So, after executing this, the final result will be available in the stack. Then it comes to this mult instruction. So, it will take out these two values, do the multiplication and put the result back onto the stack. Or if you are looking into a more detailed version, okay, so that then it will look like this. There is a code to evaluate E 1, code to evaluate E 2, then R naught equal to pop. So, that is the topmost entry is popped out and it is kept in R naught. Then R 1 equal to pop. So, that is also taken out of the stack, and then in R 2 we do this multiplication R 0 into R 1, and then we do push R 2. So, result is pushed into the stack. So, this is called P code type implementation. So, this is a high level representation. So, where it is close to the stack based representation, but the difficulty that we have is definitely if the target is a accumulator based architecture, then converting it into target code becomes difficult. So, that is there, but in still this is one of the this is a technique for doing this code generation. Okay. So, next we will be looking into the low level representations, which are very common in this intermediary code generation, which is known as 3 address code. In 3 address code, the name the name 3 address came from the fact that almost all the instructions, so they will have 3 addresses, 3 address components in it. Okay. It will have 3 address components in it, like most of the instructions are of the form x equal to y of z. So, you need to tell what is the operand y and what is, so you need to tell the these operands x, y and z, and since they are identifiers or variables or numbers. So, I will have 3 addresses for x, y and z. So, that is why the name is for 3 address code, and only one operator is permitted on the right side. So, you cannot have an instruction like x equal to y star z plus p. So, that is not possible, because on the right hand side we can have only one operator. So, if you have to write like this, then first of all you have to write like x equal to say t 1 equal to y into z, and then write x equal to t 1 plus p. So, like here, so you see that we have got an example y into z plus w into a, first t 1 equal to y into z, t 2 equal to w into a, then x equal to t 1 plus t 2. So, it is a very refined form of the complex expressions that you may have in the source language program, but at the same time it is not losing the meaning of the source language program. Okay. So, everything is maintained, but it is more elaborate, and these individual instructions that we are having or the individual statements that we are having here. So, they are very simple. Due to its simplicity, it offers better flexibility in terms of target code generation and code optimization. So, you see that most of the underlying processors, they will support this 3 address format. Okay. So, in some machines what may happen is that you have got only 2 operand instructions, some machines you can have 3 operand instructions, but whatever it is. So, it is very easy to convert these statements into that form. Okay. So, that is why this is one of the most common formats in which this 3 address code is generated by the compilers. So, we will be also discussing with this 3 address code based policy. Now, statements in 3 address code, so they are having this intermediate language that uses 3 address code usually have these types of statements: assignment, jump, address and pointer assignments, procedure call return, and there is another category called miscellaneous. Now, you see that almost all the major programming language constructs, so they are taken into consideration here. So, we have got the assignment statement, jump for go to. So, address pointer arithmetic is there, and there is a the if then statement is also there. So, we will see that will come under the miscellaneous category. Assignment statement, which forms the hardcore part of this these 3 address instructions. So, there are 3 types of assignment statements. One is like x equal to y of z. So, operator being a binary operator. Sometimes we can have an unary operator, say like there can be an operator like if x and y are Boolean variables, then I can have x equal to not of y. Okay. So, in that case this not is an unary operator. So, it takes only one operand, whereas if I say x equal to y and z, then this and is a binary operator like this. Or in arithmetic domain, so we have got this unary minus x equal to minus of y, where this minus is a unary minus, whereas if I write like x equal to y minus z, then this minus is a binary minus. So, their meanings are totally different. So, though both of them appear to be minus symbol, but they are different. So, if you are looking into any real compiler design task, then you will find that it is given to the lexicon analyzer to differentiate between these two situations. In one case it returns unary minus as a token, in the second case it returns minus as a token. So, that way sometimes it is a bit confusing. And the third type of assignment is x equal to y. So, there is no operation, the value of y is assigned to x. For all operators in the source language, there should be a counterpart in the intermediate language. So, that is must, because otherwise you will not be able to generate you will not be able to have easy code generation into intermediate code. So, you have to think about converting complex source language operators into simpler operators of this 3 address language, 3 address code, and that is that often brings loss of optimization. So, that way it is not advisable that we should have a 3 address code, this intermediate language, such that the less number of less operators are there than the source language operators. So, once that is said, so we will be looking into this operators, some more statements of this 3 address code. One is known as the jump statement. So, we have got this go to L, where L is a label. So, you can have some, so this L is again a hypothetical one, because this is for just an intermediate representation. Okay. So, in the so I can just use any symbol here as L, like in a program, sorry. So, in a program, so you can have at this point say go to L, say go to say L1, and this L1 may be a label here. Some statement may have L1 before that. So, that will mean that this label is L1. So, when it is assumed that when this statement will be executed, so it will be the control will be coming to L1. Similarly, there can be a go to L2, and L2 may be somewhere here. So, this way, so this go to L is a generic go to statement to the label L, and we have got this conditional go to. So, if x relational operator y go to L. Okay. So, this is the so if then else type of statement. So, if x relo y go to L. So, if this statement is there, so I do not need any separate if then else statement. For example, if I tell you like this, that if x greater than y, then a equal to b plus c, then say e equal to f minus g, else a equal to b minus c, e equal to f plus g, say something like this. Then I can do it like this, that I can do it. So, I can write like this, if x greater than y, go to L, say L1, and then here I write like a equal to b plus c, e equal to f minus g, then a go to L2, and this is my L1. So, where I write like a equal to b minus c, e equal to f plus g, and this is my L2. So, you see that in this language I do not need the then and else part of the if statement. So, if then else type of constructs, they can be converted into this if condition go to some level type of statements. So, that is done very often. So, we will see that these jump statements can be useful for doing this. So, it also supports some array type of structure, because array is now so common in many of the almost all the programming languages. So, if you do not support array as a basic operation in the 3 address code, then it becomes very difficult to generate the corresponding code in the target machine. So, so it becomes very difficult for converting the source language array indices to the intermediate code. So, only one dimensional array is supported. So, in your source language there may not be any restriction on the number of dimensions, but ultimately what is happening is that, see, your memory onto which you will be storing this array. So, that is one dimensional in nature. For example, if I have got a 2D array a 100 by 100, then also I will be storing them in this fashion, say a 11, a 12 up to say a 100, then a 21. So, I will be storing in them in this fashion. Okay. So, I do not need to really have a 2D representation, because while I am talking about the target code. So, target code, it will be accessing memory only in a one dimensional fashion. So, even if my target machine supports this array access, so there is no point having multi-dimensional array in the target code. So, that the target code will not support multi-dimensional array. So, this conversion from this multi-dimensional array access to single dimensional array access, it is better done at the intermediate code generation phase itself. So, that at the target code generation stage, so we do not be bothered about this array dimensions and all. So, there we can concentrate more on other optimizations. So, arrays of higher dimension, so they are converted to one dimensional arrays. So, that makes it so this conversion code has to be generated by the compiler. So, it will do that conversion, and say like I can definitely have a statement in my source language program, like say t equal to say x I j, and then in the 3 address code I should have the appropriate code, so that this x I j, so this is converted into some one dimensional array. And you know that based on the size of this array, the dimensions of this array, so you can very easily compute the corresponding index at which you have to refer to. So, that can be, that is done. In fact, it is if the array is of dimension say capital M by capital N, then each x axis is it is having say n such entries. So, this is I into n plus j. So, if you go to that, so this, if you are storing this x array in this fashion 1 1 x 1 1, then x 1 2 in this fashion, then you can do it in this way. So, that way it will be so this is not I, this is I minus 1 into n plus j. For example, if it is 1 1, then I this will be this will come to this first slot. So, if it is 1 2, then it will come to the second slot like that. So, that way it will be doing the conversion. So, any data structure book on this array, so that we will discuss on that. So, these arrays of higher dimension, they can be converted to one dimensional array, and the compiler has to embed this code into the 3 address code that is generated. Okay. So, this we will see that it is exactly what is done in the code generation phase. Okay. So, this will be done. So, the statements to be supported are only one dimensional arrays x equal to y I or x I equal to y. So, these are the two type of statements that we need to support. Now, address and pointer assignment. So, this is another very important issue. So, there is maybe a question like whether we should support these pointers or not, this address arithmetic or not. But this is required because many programming languages, they support this address pointers and all. So, if it is not supported, then it will become very difficult to convert those statements. Like suppose for example, in C language, so you have got this integer pointer int star p, and at some point you have got a statement like a equal to star p. Now, how are you going to handle, how are you going to write it in terms of some lower level language program in which these pointers are not supported? If pointers are not supported, it is really it is almost impossible to write it in a proper with proper flavor. So, you can always do something so that it will give you some other representation which will not be truly a pointer, but something close to that, but you will never get a true pointer there. And the underlying machine, so most of the underlying processors, they support this type of pointers and all. So, they support indirect access. So, that they are at the architecture level, pointers are being supported. So, the machine code that we are going to use, they are going to support pointers. So, if the intermediate code does not support pointers, then of course, that is of no use. So, that is why in intermediate code also we need to support pointers. So, statements required for pointers are like this, that x equal to ampersand y. So, address of y is assigned to x, then x equal to star y, the content of location pointed to by y is assigned to x, and x equal to y. So, this is simple pointer assignment. So, x and y both are pointer variables. So, you write like x equal to y. So, it does not tell anything about this incrementing pointers and all. So, it may be in some, if your high level language supports that, if it supports that pointer arithmetic in terms of say making x equal to x plus 1 and things like that. So, if this sort of things are supported, then you have to have those features also incorporated into the 3 address code. But for our understanding, we assume that our pointers are simple. So, we do not have any pointer arithmetic supported, okay, only pointer assignment can be there. So, in that case, this representation is good enough. Okay. So, if you are in C type of language, we have this pointer arithmetic, which is mostly used for accessing arrays using pointers, but that may not be necessary in some other programming languages. So, that way so for our discussion, so we will not take this pointer arithmetic into consideration, we will take them simply as pointer assignment. Procedure call or return. So, this is of course important. So, a call to procedure P. So, there are two part in it. So, we have to pass all these parameters. So, this is the call for handling for doing this parameter passing. So, this x 1 x 2 up to x n. So, we say that they are all parameters. Okay. So, this has to be done. Now, how these parameters will be implemented in the target language, so that is a question. So, we do not answer that at this level, but we keep a note that this x 1 x 2 x n. So, they are parameters. So, if we have already seen that in runtime environment management, so we need to create the activation record. So, once these parameter statements are found, so this compiler will know that when it is generating the target code, that there will be activation record created, and these are the parameters going to be used in the activation record. So, when the activation record will get created, in that this x1, x2, xm, so they will be given space. So, you will know how big an activation record you need to make once you know this parameter. So, 3 address code is not for execution. So, we just keep it is just for keeping a note that what will be required at the target level. So, that is what is kept here. So, this x1 to xn, so those parameters are kept, and to proceed to a procedure is implemented using the statements like enter f, leave f, return x, retrieve x, etc. So, enter f is so if I have got a procedure call. So, if this is the main routine and somewhere here I have given a call to procedure p with parameters like x1, x2, x3, then what it will do? So, it will put these param statements, param x1, param x2, param x3 like that, and then it will tell enter p. So, enter p. So, this will be after. So, when is this enter p statement comes? So, by this time the activation record has already been made. So, this activation record will be pushed into the stack, and then it will be branching to the subroutine p. Similarly, this leave f. So, this is for the cleanup actions. So, that will be called by this callee routine. So, that will be done by the callee routine. So, it will be cleaning up this activation record area and all. Similarly, this return x, retrieve x. So, this return means there is no return value. So, it will just return from the procedure. So, this return values are not there, but in return x there is a return value. So, as a result, if you have written like something like say a equal to p. So, p x1, x2, x3, then after returning. So, this whole procedure should have some return value x that will be assigned to a. So, this return value is needed. So, that is obtained by return x statement. So, the return value of p is taken into return x. So, if this is the procedure p. So, at the end of it you can have a return x statement that will do return, and this retrieve x. So, this will also save return value in x. So, that is also there. So, these are actually synonymous. So, so you can use any of these statements. So, thus we see that the procedure call return. So, basic procedure call return is also implemented in 3 address code. So, that we can also implement this procedure calls, sub program calls and returns. So, this 3 address code that we is not very simple or very low level. At the same time, it is not very high level also. So, it is exactly we can say it is exactly at the middle of the two ends, the source language and the target language. So, it is almost at the middle of the thing. So, that it is equidistant from both the sides. So, that makes it interesting, because if you want to target to different target processors. So, you can put half of the effort, you can say in some sense half of the effort of total compiler writing for generating a new compiler for the second target machine.